Hi, I'm Carl Franklin. In this episode of Blazor Train, I'll show you how to use the very popular Dapper library for SQL Server data access on the back end. And of course, we'll make a repository for Dapper, which you can reuse for any database and any entity. Dapper can be used in many ways, and I've chosen but one path. You may find ways to optimize it for your own purposes, and I really hope you do. So, let's make a Dapper repository together, right now, right here on Blazor Train! All right, well, let's start with Dapper itself. Dapper is an open source project. You can get there on GitHub, dapperlib/Dapper. As it says, a simple object mapper for .NET. It's very lightweight. It uses ADO.NET under the hood. And the whole idea with Dapper is that you don't have the overhead of creating commands and parameters and all that stuff. It sort of takes care of a lot of that for you. So it's definitely a step up from using ADO.NET directly. And if you want, you can add some other tools on top of it, which we're going to do today to make it work with Link. So performance is a big issue. It's a key feature. Entity framework is good, but it's kind of slow. And it wasn't really built for web use, as I have mentioned before. You sort of have to turn off a lot of the features that made it nice when working with a stateful Windows app, say, tracking of entities. It also does some stuff with the models by including virtual properties that map accordingly. So Entity Framework does have some nice features, but if you want to have that, table level control that you get from using ADO.NET commands directly without all the overhead of having to make your parameters and types and all of that stuff, then Dapper's a really good choice. It scales really well. And as I said, it's stinky fast. So what I'm going to start with is the repository pattern. Now, if you've seen any of the other data access episodes, you'll know that I'm a real fan of the repository pattern. So we're going to start with an interface, iRepository. And here you go. Now, this is just an interface. It's not an implementation, but we are going to implement this interface. We've done it with Entity Framework. We've done it with in-memory stores, and I've also done it with blob storage. But it's basically, you have a getAll method, you have an insert, an update, and a delete method, and you also have this really cool filtered get, where you can specify a filter, you can say the properties that you want to include, you can order the results. So this is a really powerful method right here. And believe it or not, we're going to implement this with Dapper in our Dapper repository. But before we can do any of that, let's think about the databases that we're going to use here today. We're going to start with one called Chinook. And here's Chinook. This is a free open source database. You can go grab it, just Google it. And we're particularly going to focus on the customer table. Customer ID, first name, last name, company, address, blah, blah, blah. So that's what we're going to do. However, I am going to lean on the scaffolding that I use to create the models for Entity Framework. I'm going to use that to generate the models, but we're not going to use the DB context. But even though we still need to use the Entity Framework scaffolding tools. So I've just added all the packages that I need to the CS project file. I've got Dapper, I've got Microsoft Data SQL Client, and then the tools for Entity Framework and code generation design. Next, I'm going to open my app settings JSON and add the connection string. So I called it Chinook connection string, and it is basically just looking at my local DB Chinook database right there. And I've put in a little comment here for the scaffolding command. So I'm going to open up a package manager window right now and paste that in. First, it's going to build. Then it'll generate actually a DB context, which we won't use, but also the models, and output them all to this models folder. So I'm not going to use this DB context because this is Entity Framework. And the whole idea of using Dapper is to get away from Entity Framework and use something that's more simple, lightweight, and faster. So we're going to delete that context. Now there's some weird stuff down here, right? The virtual properties. We're going to just ignore that stuff for the time being. And we're going to add to our data folder a Dapper repository. The Dapper repository is typed. So we have this generic type, tEntity, right? Because our iRepository is generically typed as well. So we've got a SQL connection string that we'll have to load in. I'm getting the entity type from type of tEntity, and also the name of that type, and I'm storing those here. So we're skipping over much of this, delete, the get with the expressions, and the insert and update. We're not going to worry about those for now. So this is a simple SQL statement, select asterisk from, and then the entity name. And we're just returning the result from this database connection, SQL connection. And we get this query async of tEntity passing the SQL statement. It does exactly what you think. It returns all of the records in that table. So how do we add this as a service? Well, let's go to Startup. Because we have to specify the entity type and also in the constructor pass the connection string. So if you recall in app settings, we called it Chinook connection string. So this is what it ends up being. Now let me qualify the namespace, Dapper demo models, and here we go. So we're adding a Dapper repository of customer, and now we have a little Lambda here that returns a new Dapper repository of customer, passing in the connection string, which we get from configuration, get connection string, Chinook connection string. Okay, before we can write any UI code, let's add a couple of using statements to our underscore imports, Dapper demo data and Dapper demo models. Finally, let's take over the index page, as I am wont to do. Okay, so we're injecting our Dapper repository of customer. We have the usual UI to call a method when we select something in a list. And then we go through all the customer objects in customers, which is my main list of customer. And if it's the selected customer, we use that selected attribute, otherwise we don't. And once we have a selected customer, we're going to show the address. And I got an error message here. We're going to need that later, but not right now, actually. Here's customer selected, and I get the ID from the args, which, as you can see, we have the value right there, customer ID. Change that to an integer, and then we can use a little link to go find in customers the record where customer ID equals that ID. And on initialized async, we're calling load all customers, where we set customers, our list, to await customer manager get all to list. Pretty simple and straight ahead. All right, let's check it out. Okay, so we click on one of these guys and we see the address. No big deal, but we can definitely do more. So let's look at our customer record, and I'm going to change it up a little bit. I'm going to add the data annotations namespace, and I'm going to specify that customer ID is the key. It's the primary key. All right, and the rest of this stuff we'll just leave as is. But I need to know which field is the primary key, because if I'm going to do any deletes, I need to use that in the where clause, or an update for that matter. All right, let's change our Dapper repository to support this primary key identity thing. We've got our SQL connection string, our entity name, our entity type, but we also have these primary key name and primary key type. And so I'm getting from the entity type all the properties where the key attribute is defined. So I should only get one back, right? That would be the first. So that's the primary key name, the first property. That should be customer ID. And this will be the type, which will be int32. That's the property type name. And if I don't find that, then I'm just guessing that the primary key name is ID and the primary key type is int32. All right, now let's look at delete. Our SQL now is delete from entity name, where primary key name equals at primary key name. And so what this will translate to is something like this. Okay, delete from customer, where customer ID equals at customer ID. So right out of the box with Dapper, you just specify an @ sign on the name of the field, and it does the rest. Because what you're doing here is calling execute async, passing in that SQL and passing in the entity. See? So from the entity, it understands, what at customer ID is. It's the value of the customer ID property. All right. Get all is the same. Now let's go down to insert. Well, insert has a special problem, doesn't it? Because if you were going to generate a SQL string, how do you do it generically when you want to end up with something like this? All right, so this is what we want to end up with. Insert into customer, first name, last name, values at first name, last name. But this is a generic repository. How on earth am I going to do that? Well, I've got to do some reflection to figure out what properties I want to include that have values. So I created this little guy, Dapper SQL Helper, that will give us an insert statement and, in the case of update, an update statement. So let me add that here. All right, I've heavily commented the get insert statement. We're passing in the entity and the table name. It's very generic, right? Object. So we're starting with insert into table name, parentheses. Now I'm getting the type of the entity and I'm getting the properties of the entity. Now, if you don't specify what properties you want, you get the public properties. So these are the things that I want to set. And this is where you can go through and filter out properties that you don't want. If you want to put certain attributes on properties that you want to include in the insert or not, you could do that and you could filter them that way. What I have is just a sample demo here that checks to see if the property is nullable. And if it is, I get the value. And if the value is not null, then I'm going to add, the property name to my list. Because remember, insert into table name, now we have the list in parentheses. Otherwise, if it's a virtual property, like customer invoices, then we want to exclude that. So if it's not virtual, we will include it. So at this point, I've got a trailing comma and space that we got to remove. So we'll do that with simple magic string formula here. And now we're going to add the start of the values clause. Close paren, values, open paren. And we go once more through the properties and we do our test again. And this time we're adding at property name. Remember, because what we want to end up with is this: insert into customer first name, last name, all of the properties, values, at first name, at last name, right? So again, we remove the trailing comma and space and then add a close parentheses. Now the insert, we only have to go once through, right? We have update table name set, property name equals at property name. And then the where clause is where primary key name equals at primary key name. All right, let's update our index page to support this. So now I've got the same select statement. I've got a button to add me as, to insert, to test doing the insert. And if I've clicked on a customer, then I've selected one. I'm going to show the address. I'm also going to have the delete and update buttons. So here's what the code does. Selected is the same. Update customer. We're going to change the address to updated at date time now toString. And we're going to call update and return the updated record if it was changed. And if it was not changed, then we're going to show the error message. Add customer. Just create some dummy data here. And I say customer manager insert, passing that, and the same thing. I get a new customer back. And if it's not null, I'm going to call load all customers to reload the list. Otherwise, set the error message, delete, pretty much the same idea. We get a Boolean back from that. And if it was deleted, we're going to clear the selected customer or set it to null and reload. And that's pretty much it. So let's see what we can do. All right, so there's that guy. Let's just try deleting this person. And we can't, because the rules of referential integrity are applying here. And we're not allowed to delete this person because that would strand their records in other places. All right, so let's add me. There I am at the top. And I'll do an update. There we go. And I'll do a delete. Bye-bye. Now let's add me again. And let's just go check out the database real quick. Isn't this interesting? Customer ID 0. Wow, why is that? Well, it's an interesting case that the Chinook database in this column right here, customer ID, if you look at the details of this, the properties, you will see that the identity flag is not on. So this database requires us to put in the primary key when we save, and the attribute does not reflect that. The attribute key doesn't say one way or another if this key is generated by the database or we require it. So we got a little cleanup work to do here, but we'll get to that in a minute. I just wanted you to be aware that that's what's happening. Let's update me again, just to show that it went into the database. You can see my address is now updated. And if I delete and refresh, there I go. So as far as the database is concerned, hey, you've got a record in here with a customer ID of 0. No problem. I can find the record by that number. It's a valid number. So let's move on a little bit to the next level. Let's talk about link to Dapper. Because this guy right here in the Dapper repository is perhaps the most powerful method. This get with the expression and all of that stuff. And I want to be able to use the same kind of link syntax to retrieve records selectively and sort them and include properties and not include other properties. I want to be able to do all that from the client side, and I don't want to have to write a million different gets or search methods in order to get the ones that I want. So we're going to use this guy, link to Dapper. It's a simple, lightweight link provider for Dapper.net. It gives us lightweight link support for a lightweight ORM. And so we're going to install the package with this statement right here. All right. Now that's going to help us do that generic get. And we're going to use this method right here to create a data context. Very, very cool. But there's another tool that we're going to use, which is Dapper Contrib. And Dapper Contrib adds these things to your database connection, right? And this is the kind of stuff that I'm looking at. Insert of T, update T, delete all, very dangerous. But I could get away with not having to construct an entire list of input fields that I want, like I'm doing now if I use this. So we're going to combine both of these libraries. And yep, this is one just called dapper.contrib. So let's add dapper.contrib. Now, dapper.contrib requires another library, System Data SQL Client. Different than Microsoft Data SQL Client. This guy requires that. All right, let's add some more stuff to our underscore imports. And let's create that data context that link to Dapper gives us right here in the data folder. I'm going to create a class called data context. This is a data context of T entity. We want to pass in the SQL connection string because it uses that as well. And then we have this data property that uses create object. And create object returns a new link to Dapper of T with that connection string. So this sort of wraps all the link to Dapper stuff in your connection string in one data context. Now, here's a caveat. We're going to remove the virtual relation properties from the models. This is a feature of Entity Framework, and when it generates the models, it also has these, the relationship models. So a customer has, in this case, a bunch of invoices, right? I'm going to replace this whole customer with one that's been cleaned up a little bit. So I took out the data annotations, and I'm using the annotations from Dapper contrib extensions. I found that if I don't name the table in the database, it has a problem with it. So name the table, customer. Now, there's a difference between key, which it also supports. All right, Dapper contrib extensions key attribute. This means that the database is going to generate the customer ID or this particular, property. But if you use explicit key, that means that we have to provide that. Now let's modify our Dapper repository one more time to give us that generic get and redo our inserts and updates. Look at this. No longer do I have to create my SQL statement and execute it, but I can just say await DB update async. Insert is a bit tricky. I'm going to skip over that for now. But get all, I took out that SQL statement and I just call get all async. And here's the magic one, the get, with the filter and the order by and the include properties. And this is the same code that's in our EF repository. Delete now just calls delete async, passing in the entity. No need to do all this stuff. All right, let's look at insert. Insert needs to handle a few different scenarios. The insert on the DB that the Dapper contrib gives us assumes that the primary key is an integer. And as we well know, there are tables where the primary key is not an integer. So we have to handle three scenarios. On the integer side, we need to know whether the primary key is generated by the database or we have to supply it. And on the string side, we have to be able to use another method from this insert. So we actually have to use my getDapper insert statement. We have to build that up. So how do we know if the primary key is not an identity? I have this Boolean here that I set right up here. So here's the key attribute, and this is the Dapper contrib extensions key attribute. So if we have the key attribute, the primary key name and property type are the same. This is the same code as before, except we're looking for key. And if you take a look, this PK not identity is false. That's the default behavior. In other words, we're assuming that the database is going to generate the ID. Where we set it to true is if we can find a property with the explicit key attribute. So if we do that, now PK not identity is true. And we're also going to do these things. So you can see that we have to be able to handle a bunch of different scenarios, and we will actually run this repository against 2 other databases that have the other types of primary keys. All right. So this is the big bad repository right here. And let's add this to services because look, now we're injecting a data context and the SQL connection string. So this services statement right here is obsolete. Let's change it with this one. So we're creating a new Dapper repository of customers with a Lambda, creating a new Dapper repository of customer, passing a new data context of customer with the connection string, and as the second parameter, the connection string itself. All right, now let's update index because I got a few nice little features in here now, such as this. Now I'm using that generic get, that filtered get. And I want to get, instead of just get all, I want to get all where the customer ID is greater than 0. And I want to order by last name. So they'll come sorted by last name. The other guys are the same, except I also have this Boolean now, can I add Carl? Which if I'm already in the list, we don't want to be able to show the add Carl button. So that's what I do here. If can I add Carl, I'm showing that button. Now we'll go through the insert and I'll show you how that works because it's a bit, it's a bit involved. Here we go. All right, now you see they're in alphabetical order. We'll add Carl. So I'm starting a transaction. Got to do that in case something goes wrong. Got the primary key property. And if the type is int32 and it's not an identity, which is the case, I'm doing a query for the highest value of the primary key name. Now we're in a transaction, right? So, it is what it is. It's not the greatest thing in the world to do this, but this is what you have to do. I'm going to get that ID and add 1 to it. So I end up with 60. Now I have to set the value into the entity because customer ID is 0. So on that property, I'm setting customer ID and I'm inserting. And then I'm committing the transaction and returning the entity. And now new customer will not be null. And the customer ID is correctly set, 60. And if we go to the data and refresh, we have to go down to the bottom now because that's where I am. Carl Franklin, Nowhere Street, Hooverville, blah, blah, blah. It's there. Now if I click on myself, I can update. That still works. And remember, we're using a different method to update now, right? There it is, updated. And if I delete, I'm gone. Yeah, so these databases are out there where there's no identity, on certain fields, and it's up to you to supply them. And, if you've got a high traffic database and a lot of people adding records and stuff, there's possibilities that there will be collisions. So that's why I don't recommend when you're building databases, if you're going to use ints for primary keys, make them identities. Just makes sense. Let the database figure it out. Okay, now let's look at a different database, one that does have an auto identity, and that's my database, BandBooker. Now, there's nothing that's going to change with this code. I'm just going to run it against a different database. So let's pull up the instrument table. And here you can see that the primary key is instrument ID. And if I click on that and we look at identity, it is indeed enabled. and we're incrementing it automatically. So this is a different situation. It's still an integer, but the database is incrementing the identity and setting it. So I'm going to add an instrument class model. And here you go. It's important, again, to set the table. And now we're just using key because it says specify that this field is a primary key in the database and also is assuming that the database will generate it. It's a very simple table, and that's why I chose it for this demo. All right, so now let's go to app settings, and we'll add another connection string, band booker connection string. Everything the same except for the database is now band booker. And this is also a good measure of what it takes once you have this plumbing in place to just add a new repository for a different database and a different entity. So here's the service, Dapper repository of instrument, data context of instrument. Here's the connection string. Those are the only things that have to change. Now we'll hijack counter razor because it's already there and I don't have to add another page. Here we go. So I've just got a test button, got my instrument manager here, and I'm just going to put breakpoints so that we can see when things get added and updated and deleted. We'll do them one at a time. Use counter. All right, instruments. We've got 3 instruments in there. Keyboards, drums, and bass. All right, so now let's go to Instrument Manager Insert. So we begin the transaction. It's an int32, but PK not identity is now false, so the key will be created by the database, and we're going to return that via insert from contrib, and we'll set that into the entity, 13. And now back in the page, my instrument ID is 13. Now I'm going to update the name because right now the name is the date. I just put the date in there. Okay, that was updated. And now, there it is. And now I'll delete it. Maybe we should take a look at the database, right? That would be a good idea. Okay, you can see that it was updated right here. We'll go ahead and delete it and refresh. There it goes. All right, so that's 2 situations taken care of. Now let's do the third. We're going to use the Northwind database, and the Northwind database has this customers table, and the primary key for customers is a 5-character string. All right, obviously not auto-generated, but it's a string. It's not an integer. So let's add a customers with an S model. Here's our table customers, and it is plural. And we have explicit key for customer ID because we have to specify that. Add the connection string to app settings. Northwind connection string. Add the service in startup. All right, same idea. Dapper repository of customers with the connection string Northwind data connection string and the data context of customers. And we'll take over, guess what? Fetch data, page number 3. All right, here's our Dapper repository of customers, customers manager, and we have the same stuff here. But when I create a new customer here, I'm going to pick a customer ID that I know isn't in the database, and I'll set the company name. We'll insert it, we'll update it, we'll delete it, all of that stuff. Let's pull up the table. We still have our breakpoint in Dapper repository, so we're good to go there. All right, so we'll go to fetch data, do click me. I've got customers, 91 records. That looks about right. Now I've created my new customer, and I'll add the customer And here we go down the list. It is not an int32, it's a string. So now I'm going to have to use my get Dapper insert statement. And you can see what that returns. Insert into customers, blah, 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 values at blah, blah, blah. And now we have to use an execute async. Now the primary key is already in there, so we don't have to add it. There's our customer ID and the company name. Let's refresh. And you can see here I am. Here's my company name. Right? The date and time. And after we update, we'll go back and refresh. Now it's been updated. And now we'll delete. And it's gone. So there you go. 3 different scenarios of how to use the Dapper repository, and it is set up to do all 3 of them. Now back to you in the studio, Carl. You know, I'm really glad I finally got around to checking out Dapper. It was fun, but now I have a whole lot of code to replace. Fortunately, since I'm using the repository pattern, I can get it all done by noon and spend the rest of the day at the beach. Or at the studio. I'm just not sure which yet. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blaze a trail.